Welcome back, guys. I hope all of you will be fine. So from today we are starting chapter 5, which is related to some discrete probability distributions, in which we will discuss some very important discrete random variables and discrete probability distributions, which has significant role in your lives and all day-to-day activities. Okay, so let us first start question 5.1. This is the first question of the exercise. So let us first see that what is this statement. A random variable x that assumes the values x1, x2 up to xk is called a discrete uniform random variable if its probability mass function is fx is equal to 1 by k, means the number of random variables are here has the same probability, and that is 1 by k for all of x1, x2 up to xk and 0 otherwise. Find the mean and variance of x. Okay, so let us first see the solution of it. Okay, so in solving it, what can we see if we have the random variables here? This is what this is. These are basically the random variables, and these are the probabilities these has. So each and every one of it will have similar probability. Okay, we can see here that, and these would be up to here x of k. Okay, these are x naught, x1, x2 up to x of k, and each one here, if these are basically k number of variables, so the probability here will be 1 by k. Okay, one of its example is the a die in which all elements are basically what? Let me first draw it. Okay, so here we have either we will have 1, 2, 3, 4, 5 and 6. Okay, so all of them will have same probability. Okay, because these are equiprobable, and this probability is what? This is 1 by 6, because here you can see that this is x of k, and here the sixth item is here the same probability as we have here, and these are basically the uniform probability distributions. Okay, so I hope you have got my point that what is mean by the uniform probability distribution. So what do we have to do? We have to find mean and variance of x of k, and it is very clear here that in order to find the mean of it here, what do I have to do? So I have to add all these items together, and what do I have to do? I have to divide them over the total number of items. So here we can do what? It would be x1 plus x2 plus x3 plus x4 plus x5 plus x6, okay, divided by the number of items, which are 6. So this is what? This can be the mean of it. Okay, this will be the mean of it. Similarly, for the generic terms here, what we can do here is that here the mean of it will be x1 plus x2 plus x of 3 plus x4 up to and until x of k divided by the k. Okay, sorry, this is k divided by k, or we can also write it what? We can also write it like from I equal to 1 up to k x of I divided by k, or 1 by k is outside of it, and then I have to add these items together from 1 to k. So this is what? This is basically the mean of the random variable which we have. Okay, similarly, if you want to find out the variance of it, the similar equation which we have seen previously would be what? That would be from it as well, it will be 1 by k, and from I equal to 1 up to k I have to take each item, and from it I have to subtract the mean and square it. Okay, this is what? This is basically the variance of the items which we have. Okay, so this is what? This is the solution of question 5.1, and this is basically the essence of the uniform random variable or uniform probability distribution which I have described in this question. Okay, so that is basically the solution of question 5.1. Let us proceed to question 5.3 because this is also relevant to the uniform random variable. So let us go through it. So question 5.3, an employee is selected from a staff of 10 to supervise a certain project by selecting a tag at random from a box containing 10 tags numbered 1 to 10. Okay, so a box we have in which we have some tags. Let me represent them with this similar tags which are numbered from 1 to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Same size and same tags, and on each of one we have numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and here on it we have 10. Okay. Find the formula for the probability distribution of x representing the number on the tag that is drawn. Okay, so these are placed inside this box and therefore each has a similar size, similar probability. So that's what this is, what this basically represents, the uniform probability distribution. What is the probability that the number is drawn less than 4? Okay, so the probability here of drawing each item is k, and this is what, this is 1 by k. The k here is 10, so therefore the probability here for this case is 1 by 10. So each item, the probability of each item here is 1 by 10. Similarly, what is the probability that the number is drawn is less than 4? So I have to find the probability that the number drawn is less than 4. So less than 4 means the probability that x equal to 1, or probability that x is equal to 2, or the probability that x is equal to 3. So 1, 2, 3 tags are selected. So what is the probability that x is equal to 1? That is 1 by 10, because all of them are equiprobable, and that is the uniform probability distribution. Similarly here, what is the probability that x equal to 2? That is also 1 by 10. And what is the probability that x is equal to 3? This is also 10. So adding them all together, what will we get? This will be 3 by 10, and that is basically the solution of question 5.3. So you have seen that how to find out the probabilities in the uniform random variables, and these two questions closely relevant with the uniform probability distributions. Okay, so if you have any question, you can ask me in the comment box. That's it for today, and I will see you with some more interesting stuff in our upcoming video. See you soon. Welcome back, guys. So this is question 5.2, and today we are going to solve it. So the statement of this question is 12 people are given two identical speakers which they are asked to listen to for differences, if any. Suppose that these people answer simply by guessing. Find the probability that 3 people claim to have heard a difference between the two speakers. Okay, so here in this type of questions, what do you have to do? What will be the approach, and how would you solve these type of questions? First of all, you have to write the given data. So in given data, we have to write the total number of people first. So let me denote the total number of people with n. So n is 12. Okay, and they have to check two identical speakers to see that whether there is a difference or not. Okay, so what do they have to do? They have to see that whether these are identical, okay, or different. Either the two would be identical or different. Okay, and there is nothing given about that how much it is probable that the two speakers will be identical or different. So therefore they are equally probable. Okay, so therefore the identical has the probability 1 by 2, and different has a chance of 1 by 2 as well. Okay, so let me represent the difference with Q and identical with P. And how did we get it? We have got it by q is equal to 1 minus p, because this is a binary case in which we have only two cases, either those would be identical or different. Okay, and we have to find the probability that three people claim to have heard a difference between the two speakers. So I have to find the case in which the people or the persons are three and there are three votes which see that the two speakers are different. Okay, so therefore we have to see the three cases in which the speakers are told to be different. Okay, so these type of questions in which we have the binary operations. Okay, so these are basically what, let me represent them with this color. So we have the binary operations or two operations. So these are basically the trials which are called Bernoulli trials. Okay, we have a trial of either 1 or 0 or true or false or good or bad. Okay, so each of the case here represents what, that is basically the Bernoulli trial, and one of the foremost case for it is basically the coin tossing. Okay, in which we can either have heads or tail. So this is what, this is a single Bernoulli trial, single Bernoulli trial, single Bernoulli trial, and single Bernoulli trial. Okay, here we can see that we have three cases in which we have to see that there is a difference between the speakers. Okay, so we have here three Bernoulli trials. Okay, also we can see that we are given the chance of each trial here as well. So these type of trials in which the total trials are given. Okay, total n are given, and we have to see the cases k for which either it is true or false, or either it is good or bad, or either it is different or identical. So these type of trials basically moves into what, this is basically the case of binomial probability. Okay, so now we have what, this is the binomial probability, and this binomial is based on bi and then nomial. Okay, so this bi is for what, this is for 2 and this is for the cases. Okay, so two cases encounters with the binomial. If we have multiple cases, so that would be what, here there we would have to represent this bi with multi, and that would be nomial. We will also try to solve questions for multinomial as well, but this question, which is the case of the binomial probability law, we had encountered it here and we are going to solve it now here. Okay, so as we have here all these cases, so let me remove it and let me see that how to solve these type of questions. So we know the formula for the binomial probability law, and that is what, that is basically the, if we want to find out the probability that the items or the uh, elements we have would be k equal to small k, it would be what, it will be the n choose k with the probability of it and then k and then 1 minus p n minus k. Okay, so here we have the probability of the differences. So this is what, this differences probability is basically p, we have to see the different items. So therefore here I want to find out the probability that we have three persons who are saying that the speakers are different. So therefore I want to find out the probability that k equal to 3. Let me put these values here. N is how much, that is 12, this is 3. Okay, p is what, this is 1 by 2. Okay, and k is 3, and also 1 minus p is how much, that is again 1 by 2, and n minus k, 12 minus 3 is 9. Okay, so let me find it out. Opening it, I will get 12 factorial divided by 3 factorial, and 12 minus 3 is 9 factorial. Okay, combining them two, I will get 1 over 2, 12. Okay, so let me move down somehow. So now what I will get, this is 12, 11, 10 into 9 factorial divided by 3 into 2 into 1 into 9 factorial. Okay, these two will cancel out, and here it is 1 over 2 raised to power 12. Okay, looking at these things here, 3, 4, 12, 2, 5, 10, and finding it out, I will get 220 multiplied by 1 over 2 raised to power 12. Okay, or 220 divided by 2 raised to power 12 is 4096, and dividing it over 8, what I will get, it would be 0.0537, and that is basically the solution of the question 5.2. Okay, so that's it for today, in which we have seen that how to see that whether a problem at hand is of binomial or Bernoulli or of uniform distribution. So that's it for today. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. I hope all of you will be fine. So this is question 5.4 of chapter 5, and the statement of this question is, in a certain city district, the need for money to buy drugs is stated as the reason for 75% of all the thefts. Okay, so if all the thefts have been carried out, so there is a 75% chance that the thieves has stolen all the stuff due to their drug addiction. Okay, so find the probability that among the next 5 theft cases reported in this city, exactly 2 resulted from the need for money to buy drugs. Okay, and B is at most 3 resulted from the need for money to buy drugs. So before going into the detail of this solution, let me first write that and see that which type of probability is that and how can we find it out. Okay, so first of all, let me see that what is given. So in the given data, we have been given that out of all the thefts, we have the probability that a thief is a drug addicted is 0.75. Okay, this is the probability. So the probability of the drug addiction is 0.75, and the probability that he is not a drug addict would be Q is equal to 1 minus P, so it would be 1 minus 0.75, so it would be 0.25. Okay, so this is the given data. After finding it out, we have 5 theft cases, and out of those 5 cases, okay, let me see that we have 1, 2, 3, 4, 5. So out of all these 5, we have to see that these are the theft cases, and out of these we have to see that either he has been stealing the stuff for buying drugs, so either it can be for the drug or no drug, it can also be drug or no drug. Okay, so here we can have drug or no drug, which is basically what, which is a binary process which can be either 1 or 0, and this binary process or this trial for true false 1 0 and all of these things is basically the Bernoulli trial. Okay, and I have told you previously that the combinations of the different Bernoulli trials give me what? It give me the binomial probability. Okay, so it is clear now here that in order to find here exactly 2 cases in which the money is stolen to buy drugs. Okay, so here what do we have to find out? We have to find here the probability that the 2 cases are reported for which the money has been stolen to buy drugs, and for them the total number of the theft cases were what? Those were 5. Okay, so this is the case of the binomial probability, and I have told you that why is it binomial probability. So let me solve it, And I have previously told you that to find the probability of any, what do we have to do? We will have here n choose k, p of k, and 1 minus p or q, n minus k. Okay, let me put all these values here for this case. So here it will be pk is equal to 2. Okay, here n is 5, k is 2, p is 0.75, 0.75, and here k is 2, and 1 minus p is q basically. 0.25, and 5 minus 3 is cube. Okay, so let me find it out, and finding it out, it would be 5 factorial divided by 2 factorial, and 5 minus 2 is 3 factorial, multiplied by 0.75 and square, and 0.25 cube. What it would be? It would be 0.00879. Okay, and at the end, when we will calculate it, okay, when we will calculate this one, the answer of it will be what? The answer of it will be 0.0879, and that is what? That is the solution of part A of question 5.4. Okay, so the solution of part A is given, and that is what the probability that we will have two theft cases for buying drugs was 0.0879. Okay, so that is the solution for part A. Let me proceed to part B of this question, and let me move down somehow for this one. Okay, so the data will remain the same, and we have to find that at most 3 resulted from the need for money to buy drugs. Okay, so at most 3 resulted means what? We have here, we want to find out the probability that the k value of k is less than or equal to 3. Okay, so the value will not exceed 3, so it can be what? It will have two possibilities. The first possibility will be, we have to find out all the values which are less than 3, so it will be the k equal to 0, or k equal to 1, or k equal to 2, or k equal to 3. This is the first possibility that we have to carry out all these calculations to find out the probability that k is less than or equal to 3. Similarly, we can also formulate another mathematical equation in which we will have this k less than or equal to 3, and that would be 1 minus the probability that k is greater than 3. Okay, so here let me expand this formula. So I will have here 1 minus this probability of k is greater than 3 will not include 3, so therefore the probability that k is equal to 4, or the probability that k is equal to 5, because the maximum value here of n is 5. Okay, so here you have to carry out these two calculations, and then you have to subtract, add them, and then subtract them from 1. So from these two cases, you have to see that whichever is feasible for you to carry out the calculation, the answer of both of them will be similar. Okay, both of the equations will give you the similar answer, but the thing here is that you have to make these things easier for you, and you have to use your common sense to see that which is better for you. So you can very easily see that this second formula is basically using the two combinatorial formulas, so therefore it is easy for me to carry out this one. So let me do it. So 1 minus this one is here, and for k equal to 4, I will have here 5 choose 4. Okay, and the probabilities will remain the same. It will be 0.75 for p, and here it will be 4, and also 0.25, which is 1 minus 0.75, it will be 5 minus 4, so 5 minus 4, which is basically 1. Similarly, for the second term here, I will have here 5 choose 5, here it will be 0.75, and here it will be 5, and also 0.25, and 5 minus 5 here I will have. Okay, so let me move down somehow here as well to see the solution of it. So here we will have what? This is the probability that k is less than or equal to 3. Okay, so here we will have 1 minus, this will be 5 factorial divided by 4 factorial into 5 minus 4 is 1 factorial, and here multiplying with these terms, this will be what? It will be 0.079. okay, combining them both, because 0.25 and raised to power 1. Similarly here I will have 5 factorial divided by 5 factorial into 0 factorial, and multiplying these terms, because it will become 0, and anything raised to power 0 is 1, so it will be what? It will be 1. And here it will be 5 factor 5, these two will cancel out, and here we will have 0.237. okay, so here it is what we have. So now let me have here 1 minus, here multiplying it, I will get 5 multiplied by 0.079, so it will be what? It will be 0.395 plus 0.237. okay, so carrying it out, adding them together, and then subtracting it from 1, what I will get here? The answer of it will be 0.3672. okay, and that is what? That is basically the solution of part B of my question. okay, so in this part of question you have seen that how to formulate the strategy to use minimum calculation to reach to the answer of the any part of the question which is related to the binomial probability by using the probability theorem or axioms of the probability. So that's it for today. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. I hope all of you will be fine. So we have started chapter 5 and we were discussing the binomial probability theorem or binomial distributions. So today we are going to solve question 5.5 and 5.6, which are closely relevant with each other, and both of them are basically the problems of the binomial probability distribution. So let us first go through question 5.5, and the statement of it is, according to chemical engineering progress, approximately 30% of all pipework failures in chemical plants are caused by operator error. okay, so this is basically the probability of the operator error. So let me write the given data as well. So the given data, this is 5.5, and for 5.5 the given data is what? The probability of the operator error is probability of error, or let me represent it with P. So P is 0.3, which is 30%, and therefore the probability that the pipe failures are not due to the operator error are Q, and that is 1 minus P. So 1 minus P is 0.7. okay, so you have to keep it in your mind that this is the probability of the failures in chemical plants due to operator error, and this is the failures in the chemical plant which are not due to the operator errors. okay, so let us go through the questions. What is the probability that out of the next 20 pipe work failures, at least 10 are due to the operator error? okay, so what do we have to find out? We have to find out the probability that total pipe works are 20, so it means that the n here are, let me remove it first, the number of total pipework failures are 20, and out of these 20, at least 10 are due to operator error, or k is greater or equal to 10. okay, so what do we have to find out? We have to find out the probability that k is greater or equal to 10, and this would be what? We can see that this would be from 10, probability that k equal to 10, okay, up to what? Up to the probability that k equal to 20. Okay, we have to find out all these probabilities. Similarly, we can also do it by another formula as well, and that would be 1 minus the probability that k is less than 10. Okay, so after finding them out, we can insert all these values here, and we will see that the output of it will be the values which we have to find out. Okay, so let me use this formula. So here, by using this formula, what will I have here? I will have 1 minus pk is less than 10. So therefore I have to use all these values from 0 to 9. So therefore we will have here k equal to 0 up to 9, and here we have to use the binomial probability law. Here would be n to k. Okay, and the probability of it, and this would be 0.3 k. Okay, and also here 0.7 n minus k. Okay, so here we will have it. Let me put all these values, because the value of n will remain the same here. So let me put the value of n here, and n is 20. So 20 here, okay, and 20 here as well. Okay, so we have to find them out, all finding them and then adding them together. The output of it will be what? 0.0480. Okay, so that is what, that is basically the solution of part A of my question. Similarly, in part B of question, what is the probability that no more than 4 out of 20 such failures are due to the operator error? Which means that in part B, I have to find out the probability that no more than 4 out of 20 such failures are due to the operator error. No more than 4 means k is less than or equal to 4. Okay, which means here I will have all the values of k from 0 up to what? Up to the probability that k is equal to 4. Okay, so here it will be what? It will be again the same formula, but here now the values are from 0 to 4. So here it will be k equal to 0 up to 4. Okay, and here n is 20. Okay, this is k, and the probabilities here will remain the same, 0.3. Okay, this is k, and also 0.7, and n minus k, which is 20 minus k. Okay, so that is what, after finding it out, okay, all putting all the values of k here, what will we get? We will get the output of it, and this would be what? Let me move down somehow. So moving down somehow, what will we get here? The answer of it will be 0.2375. Okay, so that is what, that is the solution of part B of my question. Okay, in part C, we have to find that suppose for a particular plant that out of the random samples of 20 such failures, exactly 5 are due to the operator error. Okay, so let us first find that what is the probability that exactly 5 are due to the operator error, and after it we have to see that whether those are basically 30% figure stated above applies to this plant or not. Okay, so let us first find the probability that exactly 5 are due to the operator error out of these 20. So here again, by using here the probability that k is equal to what? 5. Okay, this is a single value here. So using the binomial theorem here, for 20 choose k. Okay, and here 0.3, and the value of k here is 5, and 0.7, the value of k is n minus k, so those, that would be 15. So finding it out, what I will get here, the answer of it will be 0.1789. okay, which is what, you can see that this value is less than the value which is given, okay, here 30%. So it means this value is basically the viable value, and it applies to this plant as well. Okay, so that is what, that is basically the solution of question 5.5. okay, let us move to question 5.6 and see that what is it asking us. According to a survey by the Administrative Management Society, 1/2 of US companies give employees 4 weeks of vacation after they have been with the company for 15 years. Okay, so there are basically one half of the US companies which give the vacation to the employees which are with them for 15 years. Find the probability that among 6 companies surveys at random, the number that gives employee 4 weeks of vacation after 15 years of employment is anywhere from 2 to 5 and fewer than 3. Okay, so first of all, let me see that what is here the given data. This is question 5.6, and in given data, what should be the probability? The probability will be here either the company gives vacation to its employees or not. So here therefore the probability that a company gives its employees the vacation, okay, and that is 1/2, so it would be 0.5. Okay, what is the probability that a random company in the US will give the vacation to the employees which are for 15 years is 0.5, and the companies which do not give the vacation is again 1 minus 0.5, so it would be 0.5 here as well. Okay, so out of it, what do we have to find out? If 6 companies surveyed at random, okay, so which means n is 6, and we have to find out of them that the number that given employees 4 weeks of vacation after 15 of employment is anywhere from 2 to 6. So means, what do I have to find out in part A? I have to find out the probability of k that is greater or equal to 2 and less than or equal to 5. Okay, so I have to find out. How can we find it out? It can be found out by using the same formulation, that I will have the probability that k is equal to 2 up to what? Up to the k is equal to 5. Okay, so let me apply the same formulation as we did here. So let me start here, k from 2 up to 5. Okay, and n is here 6 due to the formula which I have stated earlier, and that is basically the formula for the binomial probability distribution. So 6 and here k. Okay, and the probability here is 0.5 of the vacation, so here 0.5 k and also 0.5 n minus k, so it would be 6 minus k. Okay, so that is what, that is basically the formulation, and here in order to find it out, we have to find all these values, and after finding them out, what will I get here? The values, you have to calculate them, and here the answer of it will be given here. Okay, similarly, in another part of it, we have to find that the companies which give the vacation are fewer than 6. Okay, so fewer than 6 means the probability that k is less than 3. Okay, which means here the companies will be from 0 up to 2, because 3 doesn't lie within this range. So therefore all these value will be here, due to this will be 6 k. Okay, and the probability is 0.5, and it would be here what? It will be k and again 0.5, which is q. Okay, this q, and it would be 6 minus k as well. Okay, so you have to find these values here as well, and this will give you the probability of the question 5.6 part B. Okay, similarly, this is the solution of what? This is solution of part A. So that's it for today, in which we have seen the application of binomial probability theorem for a variety of applications which we have here. So if you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. This is chapter 5, and today we are going to talk about question 5.7, 5.8 and 5.9. So these 3 questions are closely relevant with the binomial distribution, and these are relevant with each other, so that's why we have been covering it in a single video. So let us talk about question 5.7 first, and the statement of it is, one prominent physician claims that 70% of those with lung cancer are chain smokers. Okay, so all the patients which have a lung cancer are 70% of them are basically the chain smokers. If this assertion is correct, so part A of it, find the probability that of 10 such patients recently admitted to a hospital, fewer than half are chain smoker. Okay, so let us first see the solution of it, and we can very clearly see that this question is again based on the Bernoulli trials, and certain Bernoulli trials in which there are basically 10 patients or 10 trials, and out of them we have to see that fewer than half are chain smokers or fewer than half of them are basically true. Okay, so that is basically true or false. True means that a person who has a lung cancer is basically a chain smoker, and false is that a person who has a lung cancer is not a chain smoker. Okay, so how many of the trials we will have here in part A of it? We will have n equal to 10. Okay, and the probability that out of the all lung cancer patients, the chain smokers are basically 70%, so the probability here would be 0.7. okay, what do we have to find out in part A? We have to find that fewer than half are chain smokers, or half of this is 10, so we have to find the probability that k is less than 5, which is basically the probability that k is less than or equal to 4. Okay, so here we have to see that what is the probability that fewer than half are basically the chain smokers. So how can we do it? By using the binomial probability law, we have to write here the total number of trials or total number of patients, and here k is basically the number of the patients out of them which has the lung cancer, and then we have to use here the probability of it, which is k, and then 1 minus p and minus k. Okay, here we can see that we have here the number of patients who has basically the lung cancer, so this is a separate formula for a single item, but here as we have been doing it for different items, so here we will have here probability that k is less than or equal to 4. It will be from p k equal to 0, all the values which corresponds with this condition would be here, and also probability that k is equal to 1 plus probability that k is equal to 2 plus probability that k is equal to 3, and also the probability that k is equal to 4. okay, so these all values are basically corresponds with these values. Here we have to see that here I have to put all these values which will be here, so putting them here, what will I get here? I can cumulatively write them here as well, k equal to 0 up to k equal to 4 here, and choose k, probability of k, and 1 minus p and minus k. okay, writing these values here, what I will get from k equal to 0 up to 4. okay, and is what? N is 10, and here the values of k will be here, and p is 0.7, 0.7k, and 1 minus p is 0.3, and here it would be 10 minus k. okay, so taking all these values for all of them, which is here, 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 and here, you have to find them all by using this formula, okay, which is cumulatively like this one, and then putting them here, adding them together, you will get the answer of this question, which is part A. I'm not going to write the answer of it. You have to calculate it yourself, and you will see that the answer of it will be the same as it has been given in the answers of the book. Similarly, in part B of it, find the probability that 20 of such patients recently admitted to a hospital, fewer than half are chain smokers. Okay, so the condition here has been changed. Let me move somehow downwards, and here the condition is, this is part B, and here we can see that the number of patients are now 20, and we have to see the probability that fewer than half are chain smokers, so fewer than half here is 10, so here k is less than 10, or it would be probability that k is less than or equal to 9. okay, in order to find it out, again we will have probability of k is less than or equal to 9, so this would be from k equal to 0 plus k equal to 1, okay, up to what? Up to the probability that k equal to 9. Again using the same formula for which k is equal to 0 up to 9. Here we will have n choose k, so n is 20. This is k now. Probability will remain the same, which is 0.7, and it is k, and 1 minus 0.7 is 0.3. So n minus k, 20 minus k. Finding them all, what you will get? You will get the answer of part B, and here you will have to use this formula for all of these items and then add them together. You will get the answer of it. Okay, so that is the solution of part B. And you have been seeing that we have been using the binomial probability law, and it is very handy in such type of question which I have told you that how to find out, in which we have the number of Bernoulli trials and you have to find out the certain sequences in which this condition is true or false. Okay, so that is basically the solution of part B of mine. Now let us move to question 5.8, and the statement of it is, according to a study published by a group of University of Massachusetts sociologists, approximately 60% of the Valium users in the state of Massachusetts first took Valium for psychological problems. Find the probability that among the next 8 users from this state who are interviewed, exactly 3 began taking Valium for psychological problems, and at least 5 began taking Valium for problems that were not psychological. Okay, so first of all you have to see the probability, that what is the probability that the Valium users were having the psychological problems or using the Valium for the psychological problems, and that is basically what this is 60%, which is 0.6. okay, and the total number of users which have been used for the trials are basically 8, so n will be equal to 8. okay, so the part A of it, on the basis of it, on part A of it, we have to see that exactly 3 began taking Valium for psychological problems. So I want to find the probability that k is equal to 3. okay, this is very easy, and in order to find it out I have to use the binomial probability law, which is n k p of k and 1 minus p n minus k. okay, let me put these values. So the value of n is 8, the value of k is 3. okay, it will be here. The value of p is 0.6, 0.63, and 1 minus p, 1 minus 0.6 is 0.4. okay, so it will be n minus k, so 8 minus 3 is 5. okay, so by using it you have to use what? It will be 8 factorial divided by 3 factorial. 8 minus 3 is 5 factorial. It would be 0.6 cube and 0.45. okay, so by solving it you will get the answer of your question, which is here. So it is very easy. In part B of my question, at least 5 began taking Valium for problems that were not psychological. okay, so now we have to see that here the problem is different. Here we have seen them that exactly 3 taking Valium for psychological problems, while here these are not for the psychological problems, which means we have here the probability of the positives for this one would be 1 minus p, and that would be 1 minus 0.6, and it would be 0.4. okay, you have to keep in your mind that here the not psychological is basically the opposite of it. So therefore what we will have to do here, we have to find the probability that k prime, which is the not psychological, is having the range which is at least 5. At least 5 means k is greater or equal to 5. okay, and we can also find it out by 1 minus probability of k prime is less than 4. okay, so here we have to do what? 1 minus probability that x is, let me remove it first, so removing them first because this was a previous question. okay, so let me write it here. 1 minus k prime is less than 4. it would be what? K prime is equal to 0 plus and up to the probability that k prime is equal to 4. okay, so let me write the formula here. Here it would be 1 minus k prime is equal to 0 up to 4, and here it would be n, and n here is what? And here is the same, which is 8. okay, 8 k prime, but here the probability of it will be the change one, and that is the positive probability, which is 0.4, 0.4, and here it would be k prime, and also here 1 minus 0.4 here would be what? It would be 0.6, which is basically originally positive, but here in this case it is negative, because negative of negative is positive. Okay, you have to keep in your mind that here not psychological problems users are basically 0.4, while the psychological problem users are basically 0.6 probability. Okay, and here I have to write here 8 minus k prime. Okay, so you have to find it out, and it will be basically the answer of 5.8 part B. Okay, so that is basically the solution of question 5.8. and what was basically the twist? I have told you here that it was a twist, and you have to be very attentive to the statements, and you have to see that what is required. Now going to question 5.9, let me remove it first. So in question 5.9, in testing a certain kind of truck tire over rugged terrain, it is found that 25% of the trucks fails to complete the test run without a blowout. Out of the next 15 trucks tested, find the probability that 3 to 6 have blowouts and B is fewer than 4 have blows out. So here again you have to first see that what is the probability of blowing out, that is 0.25, and what are basically the total number of trucks? Those are basically what? 15. Okay, in part A, what do we have to find out? We have to find the probability that the trucks blown out are basically ranges from 3 to 6, are greater or equal to 3, and less than or equal to 6. Okay, and here it would be what I have to use here. Again, k is from 3 to 6, and here it will be n k. The probability of it will be 0.25, 0.25, and here k, and 1 minus 0.25, 0.75. Okay, and here n minus k. It will be like this one. For part B of my question, fewer than few have blows out. Okay, so I have to find out the probability that k is what? K is less than 4. Okay, and this is what we can very easily see, that it will be from k equal to 0 up to k is equal to 3. Okay, you have to find them out all, and here the answer of it will be the solution of part B of it. And you can also write it like from k equal to 0 up to 3, and here n of k. Okay, probability of k, and here 1 minus p probability, and n minus k. Okay, so this is what this would be the solution of part B of question 5.9. so that's it for today's video, in which we have seen the solution of question 5.7, 5.8, 5.9. Though I did not give you the answers have been listed in your textbook as well, but you have to see that what are basically the conceptual overviews, how to see that whether a problem is relevant with the binomial probability law, and how to solve them, what are the approaches. And that's it for today's video. If you have any questions, you can ask me in the comment box. See you soon. Welcome back, guys. I hope all of you will be fine. So this is chapter 5, and today we are going to discuss question 5.11, 5.12, and 5.13. Okay, so let us first talk about question 5.11. Okay, so the statement of it is the probability that a patient recovers from a delicate heart operation is 0.9. What is the probability that exactly 5 of the next patients having this operation survive? Okay, so survival is basically the positive, while not survival is basically the negative or false. Okay, so therefore we have to find out the probability that 5 patients out of 7 will have to survive. So therefore this is the probability of the survival, and it is what? This is 0.9, and the probability of no survival would be how much? That would be q, and it is 1 minus 0.9, so it would be 0.1. Okay. Similarly, the total number of patients here are n equal to 7, and we have to find that exactly 5 of them basically survives. Okay, so k is 5 here. What do I have to find out here? I have to find the probability that k is equal to 5, and again we can see very clearly here that this is the problem of the binomial probability distribution. Okay, so for this part we have this one, and for it we clearly know that the formula for the binomial probability distribution is n choose k. Okay, probability raised to power k and q, which is 1 minus p, that is n minus k. Okay, so we have all these values here. Let me put them here one by one. So this is 7 choose 5. Okay, for this one here, and the probability here is 0.9, so 0.9 raised to the power 5. Okay, and q is 0.1, and 7 minus 5, because n minus k is 7 minus 5, so here it will be square. Okay, so let me find it out. 7 factorial divided by 5 factorial, and 7 minus 5 is 2 factorial. Similarly, finding them out, 0.95, 0.1 square. Okay, so then ultimately calculating and finding it out, what will be the answer? The answer here will be 0.1240, and that is what? That is basically the solution of question 5.11. Okay, so this is the solution of question 5.11, and we have done it. Now let us move toward question 5.12, and the statement of it is: a traffic control engineer reports that 75% of the vehicle passing through a checkpoint are from within the state. Okay, so let me write this given data here. So question 5.12. Okay, and this is the given data, and in given data the probability that the vehicles are within the state are 75%. So the probability of within state is w, and this is 0.75. okay, so what is the probability that fewer than 4 of the next 9 vehicles are from out of the state? Okay, so from this probability we can very clearly see that if the probability that within the state vehicles are 0.75, the probability that out of state, okay, out of state is what? Or let me write it with O. Out of state it would be 1 minus 0.75, or it would be 0.25. Okay, so now what do we have to find out? What is the probability that fewer than 4 of the next 9 vehicles? Here n is 9, and here we have to find the probability that k is less than 4, and we have to find the probability that k is less than 4, and here we can see that these are out of the state, means this is the probability which we were seeing. Okay, so this is the probability for the true, and this is for false, means this is q here and this is here p. Okay, so let me solve it here. Let me move down somehow. Okay, so I hope this statement is now clear to you guys. So finding the probability that k is less than 4, so it is what? It is the probability that k is less than or equal to 3, which is what? Which we can find out very clearly by all the values of k which are less than or equal to 3. So k equal to 0 plus k equal to 1 plus k equal to 2, okay, and plus k equal to 3. Okay, we can also write it like here. Let me use another color for it. Let me use this blue color. So we can also write it like the probability of k equal to 0 up to 3, okay, and writing the formula, because each one here corresponds with the binomial probability law. So here n choose k p of k, okay, and q would be n minus k, okay. Similarly, using the binomial probability formula for each one of them here, what would I get here applying this formula for all of them? What would I get here? The answer of it would be 0.8343, okay. So that is what, that is basically the solution of question 5.12. okay, so you have seen that what is the difference between this and the other question is that here p and q are different from whatever is given, so you have to keep your eyes on the required things, that what is required. So out of the state required, while within the state probability has been given. Similarly, for question 5.13, a nationwide survey that examined attitudes about antidepressant revealed that approximately 70% of respondents believe antidepressants do not really cure anything. They just cover up the real trouble. Okay, so that is basically a belief which 70% of the patients basically believe in. According to this study, what is the probability that at least 3 of the next 5 people selected at random will hold this opinion? Okay, so from the overall population, the probability of holding this opinion is 70%. Okay, so let me solve it here. This is question 5.13. so the probability of holding this opinion is 70%, which is 0.7, and the probability of not holding this opinion would be 1 minus p, or 1 minus 0.7, and that would be 0.3. okay, so I hope you have got it. So now the next selected people are basically 5, so n is 5, and we have to see that at least 3 of the next people basically hold this opinion. So we have to find out that the probability that k is greater or equal to 3, and it would be what? It would be k equal to 3 plus k equal to 4, okay, and plus k equal to 5. okay, so these are basically all the values, and this is again the case of the binomial probability law. So let me again use the formula for k equal to 3 up to 5, and n choose k, okay, and probability k while q n minus k. okay, putting values here, what I will get, k equal to 3 up to 5, n is how much? N is 5, okay, this is k, and p is how much? That is 0.7, 0.7 k, and q is 0.3, and it would be 5 minus k. okay, now solving it and then finding all the values here, we will very clearly see that solving them individually for all the values of k and then adding them together, it is very easy to see that the answer of it is 0.8369. okay, and that is what, that is basically the solution of question 5.13. okay, so that's it for today, in which we have seen some use cases of the binomial probability law and how can we apply the probability distribution function, which is in the form of the binomial probability. So that's it for today. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. I hope all of you will be fine. So this is question 5.14. and the statement of it is the percentage of wins for the Chicago Bulls basketball going into the playoffs for the 1996-97 season was 87.7. okay, so this is the probability of winning. Round the 87.7 to 90 in order to use table A.1, which is given in your book, and as we are not going to use the table A.1, but let us assume that we have been rounding it from 87.7 to 90, so that's why probability here would be 0.9. so therefore the probability of losing would be q, which is what, which is 1 minus p, and p is 0.9, so 1 minus 0.9 is 0.1. 1. Okay, so on the basis of this data, what do we have to do? We have to find the answers of some parts of it. So part A of this question is, what is the probability that the Bulls sweep 4-0 the initial best of 7 playoff series? Okay, so initially this sweep means the Bulls has to do what? It will play 4 games, and out of those 4 games it has to win all of those 4 games. Okay, so therefore again this is the problem of the binomial probability law, and I have to find the probability that k equal to 4, and this is 1. The formula of it is n. Choose k, p, k, q, n minus k. Okay, let me put all these values here. So n is 4, k is 4. Okay, according to this here, and p is 0.9, 0.9 raised to power 4, and 0.1. 4 minus 4 is 0. Okay, so here what would we get? Here it would be 4 factorial divided by 4 factorial into 0 factorial, because 4 minus 4 is 0. Here it would be 0.9 raised to power 4, 0.1, it would be 1. Okay, multiplying all those terms, these will be cancelled out, and finding the 0.9 raised to power 4, what would I get? Here answer of it would be 0.6561. Okay, and that is what? That is the solution of part A of my question. Okay, now in part B, what is the probability that the Bulls win the initial best of 7 playoff series? So winning the playoff series means that it is playing best of 7, and in best of 7 it will win the series if the winning is greater or equal to 4, means all the values of 4, 5, 6, 7, it means winning the series. So therefore what do we have to find out? We have to find the probability that k is greater or equal to 4, which is what? Which is probability that k is equal to 4 plus probability that k is equal to 5 plus probability that k is equal to 6 and plus probability that k is equal to 7. Or we can also write it like from k equal to 4 up to 7, we have to find all the probabilities that k is equal to small k. This is, let me have here, this is small k, or as this is what? This is the problem of the binomial probability. So that's why writing it like this one, k is equal to 4 up to 7, here writing the formula for the binomial probability law, which is n. Choose k. Okay, p is k and q is n minus k. Let me write all these values here. Here it would be k equal to 4 up to 7. Okay, the value of n is now what? This is now 7, because the games here are basically 7 games which has been written here as well, and all the values of k would be from 4 to 7, because this is the winning, and we have been leaving it here because putting them all together and then adding them all will give us the answers. And here the probability of it is, or the probability of winning is 0.9, which is the same as mentioned here. So 0.9 raised to power k, and q is what? Q is 1 minus p. So 1 minus p is how much? That is 0.1. So 0.1, and here 7 minus k, which is n minus k. Okay, given here as well. Now after finding all these values and adding them together, which you can do very easily, the answer of it would be what? The answer of it will be 0.9973. Okay, so that is what? That is the answer of part B of my question. Part C is, what very important assumption is made in an answering parts A and B, and that is the only assumption which is already given in the statement is, and that is the rounding of the winning from 87.7 to 90%, and that is the probability that is 0.9. Okay, so this assumption has been made, which is common in all of them. You can see that it is already given here that the probability of winning is 0.9. Here it is also 0.9. So this is the only assumption which has been made. So that's it for today, in which we have seen the solution of question 5.14. So see you soon. Welcome back, guys. I hope all of you will be fine. So this is question 5.15 of chapter 5. And the statement of this question is, it is known that 60% of the mice inoculated with a serum are protected from a certain disease. Okay, so the probability that a mice has been protected is 60%. Let me write this given data here as well. Let me write it here. So the given data, the probability that the mice are basically protected from the disease are what? This is 0.6. Okay, because this is 60%. So if 5 mice are inoculated, find the probability that. Similarly here, the number of mice here are 5. Okay, similarly from it we can also do what? We can see here that if the probability that 0.6% of the mice are protected, so the probability of the disease contraction is basically contracts. This would be what? This would be 1 minus 0.6, which is 0.4. Okay, so now this is what we wanted to have. So on the basis of this statement, on the basis of this data, what do we have to do? We have to find that the out of those 5 mice, none contracts the disease, fewer than 2 contracts the disease. Okay, and C, more than 3 contracts the disease. Okay, so let me first solve part A of my question. So in solving it, this is part A, and in part A we have to find that none contracts the disease, and here we can very clearly see that this is a Bernoulli trial in which we have either the protected or contraction or non-protected. Okay, so this contracts is basically the true and this is false, and similarly on the basis of it we call this is basically P, which is 0.4, and this basically Q, which is 0.6. Why? Because here we can see that we have to find the probability of the contraction. In each statement here we have to see that what is the probability that the certain number of the mice are contracted. So therefore I have been taking this probability as the positive one, while this one is for the negative one. Okay, so I think it is clear now. So now in order to do so, we can very clearly see that these are basically the number of Bernoulli trials. So in order to find the probability of certain Bernoulli trials, we have to use the binomial probability law. So here, in order to find that none contracts the disease, we have to see that K is equal to 0, which is mean by none. Okay, so here we have to use and choose K, P of K and Q of n minus K. Okay, we have all these values. So let me write the value of n, which is 5, choose 0, which is given here, and P is what? This is 0.4. Okay, with respect to 0, and Q is what? This is 0.6, and it would be 5 because 5 minus 0 is 5. Okay, let me find them out. So it will be 5 factorial divided by 5 factorial into 0 factorial. It would be what? Something raised to power 0 is 1, and 0.6 raised to the power 5 is how much? This is 0.0778. Okay, so these will cancel out. This is equal to 1, and ultimately the answer of it would be 0.0778, and this is what? This is the solution of part A of my question. Okay, so this is what I have found out. Now let us move to part B of my question. Fewer than 2 contracts a disease means we have to find out the probability that K is less than 2, which is what? which is the probability that k is equal to 0 plus probability that k is equal to 1. Okay, as we have already found out the probability that k is equal to 0, we can also write it here in this question, and this would be 0.0778. okay, let me find it out, and it would be what? It would again be the binomial probability theorem, and writing and choose k, we will have here 5 1, probability is 0.4, writing with raised to power k, which is 1, and 0.6, and it would be 5 minus 1, this is 4. Okay, finding it out and calculating all the values, the answer of it would be what? The answer of it would be 0.3370. okay, that is what? That is basically the solution of part B of my question. Okay, let me move down somehow to solve part C of my question. Okay, so let us move to part C, and the part C of my question is more than 3 contracts the disease, means probability that k is greater than 3, or it can also be 1 minus probability that k is less than or equal to 3. okay, whatever is feasible for you, you can do it, but in this scenario we can very clearly see that probability that k is greater than 3 will be easier for me if I find out for the probability that k is equal to 4 plus the probability that k is equal to 5. okay, so this is what we have. Let me move down somehow. Okay, here, so writing the values here, and this is again the binomial probability law, so it would be and choose k, p of k, q of n minus k, plus again here and choose k, p of k, q of n minus k. okay, writing these values here, the value of n will remain the same, which is 5, while k is 4. okay, here, and the value of p is how much? This will again remain the same, this is 0.4 with 4, and q is how much? That is 0.6, and n minus k is 1. okay, similarly here we have 5, choose 5 because here again we have 5. okay, p is how much? It will remain the same, this is 0.45, and q is 0.6. okay, raised to power 0. okay, solving them all, so ultimately the answer of it would be 0.0870. okay, and that is what? That is the solution of the question we have found out. okay, so in doing so and writing the answer directly, I assume that you can do all these calculations manually as well, because here this is what? This would be 5 factorial divided by the 5 factorial, and it will be 5 minus 5, it will become 0 factorial, and here it will become what? It would be 5 factorial divided by 4 factorial, and then 5 minus 4, which is what? This is 1 factorial, and this is why? Because here I have been using the formula that n factorial divided by k factorial and minus k factorial, and this is for what? Let me remove it. This is for what? This is for n, choose k, and I have been using it all in this question. okay, so that's it for today, in which we have seen the solution of question 5.15. if you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. I hope all of you will be fine. So this is question 5.16 of chapter 5, and today the statement of the question is: suppose that airplane engines operate independently and fail with the probability equal to 0.4. okay, assuming that a plane makes a safe flight if at least one half of its engines run, determine whether a 4-engine plane or a 2-engine plane has the higher probability for a successful flight. Okay, so here we have, you can see that the two scenarios in which either we will have 4-engine plane or 2-engine plane. Okay, and we will also try to divide this question into two parts, but before it, first of all, let us see that what is the probability of the engine failure or success. So the failure probability here is 0.4. So the probability of failure is basically here, and this is P of F. P of F is what? This is 0.4. So on the basis of it, we can also find the probability of success as well, and that would be what? That would be 1 minus the probability of failure, and it would be 1 minus 0.4, which is what? 0.6. Okay, so this is what? 0.6. Let me take it and move it from here to the other side. Okay, let me place it here. Okay, so now here, in order to solve it, what do we have to do? We have to keep it in two cases. Okay, we will have case 1 and we will have here case 2, and in those two cases we have to see what? We have to see that what is the probability of success in these two cases. Okay, so in case 1 we have the number of engines equal to 4, and in case 2 we have the number of engines equal to 2. Here we can see that these are the two cases, 4 engine and 2 engines, and in each of these cases we have to see that what is the probability that the number of engines operate successfully are half or greater than it. So therefore here the value of k is half of it, that is 2, and here the number of engines half here are basically 1. Okay, what do we have to find here? Here we have to find here the probability that the k is greater or equal to 2, and here we have to find that the probability that k is greater or equal to 1. Okay, so I hope it is now clear. Now let us proceed to case 1, and here in order to find it out, we can very clearly see that this is also equal to 1 minus the probability that k is less than 2. Okay, also let me do it like this one, that 1 minus probability of k is less than 2 would be what? It would be the probability that k is equal to 0 plus the probability that k is equal to 1. Okay, and this is basically the case of the binomial probability, because again we have two cases, failure and success, and this success is basically the true case, which is P, while this failure is what? This is false, which lies in the Q, because here we have to find the successful flight. Okay, so for the successful flight we have, this is the success rate, and we have to use it here. Okay, so let me use it here, the binomial probability law, and here what would happen, and choose k multiplied by the probability of success and q then. So here the number of n's here are basically 4, so n, choose k, and then p, and then q, p, k, qn minus k. Okay, and also here for k equal to 1 we will do the same, and k probability k q of n minus k. Okay, this is here. Let me move down somehow. Okay, and here in order to do so, let me put values here. The n here for the first case is 4, choose 0. Okay, the probability of success is 0.6. Okay, 0.60, and this is q, this is 0.4, and minus k is 4. Okay, similarly here 4, choose 1, the probability of k, this is 0.6 raised to power 1 and 0.4 cube. Okay, so let me solve it again. 1 minus 4, choose 0 will be 1, 0.6, this will also be 1 because anything raised to power 0 is 1. So here we will have 0.4 raised to power 4 plus 4, choose 1, this is 4 multiplied by 0.6 plus 0.4 cube. Okay, so in solving it, what will I get? It would be 1 minus 0.1792 okay, which will ultimately give me 0.8208. So this is the solution for the case 1 where the number of engines are 2 and the success of getting operational engines greater or equal to 2. Okay, this is for the case 1. Let me proceed to case 2 and let me separate them out. Okay, this one. So this is case 2, and here in order to find out this one, I can very clearly see that this is 1 minus probability that k is less than 1. So it would be 1 minus probability k is less than 1 is k equal to 0. Okay, using the binomial probability law again. So here 1 minus, now n is 2, choose 0. Okay, and the probability of success will remain the same, which is 0.6, and k, and also 0.4, and minus k, which is square. Okay, so 1 minus 2 choose 0 is what? This is 1 minus this would also be 1, and here 0.4 square. Okay, so it will be 1 minus 0.16, or the answer of it would be 0.84. Okay, so the solution of it is 0.84. So we can very clearly see that the probability of the success here is higher for the number of engines where the number of engines are equal to 2, which is very astonishing. And we can see that by increasing the number of engines, if the success rate is the same, which is 0.6, we can see that the higher successful flight will be made if the number of engines will be equal to 2, as we can see here, because here the success rate is 0.6. okay, and the other condition is that if half or more than half of the engines are in operational mode. Okay, so that's it for today, in which we have seen the performance of the binomial probability law in decision making for the airplane engines operation. If you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. I hope all of you will be fine. So today we are going to talk about question 5.17 and 5.18 of chapter 5. These two questions are closely relevant with each other, and today we are going to talk about the mean and variance of the binomial probability distribution. So mean of the binomial probability distribution can be written as NP, where n is basically the number of items and p is the probability of the positive or probability of the happening of something. Similarly, variance of the binomial probability distribution can be written as np 1 minus p. Okay, as 1 minus p is q, so therefore it would be np q. Okay, it is represented as sigma square, and this is what? This is mu. Okay, so this is what we have to utilize today. And in question 5.17, we have to see that if x represents the number of people in exercise 5.13 who believe that antidepressant do not cure but only cover up the real problem, find the mean and variance of x when 5 people are selected at random. Okay, so here in question 5.17, okay, let me write here the given data with it. Here the number of items or number of people are basically 5, and what do we have to find out? We have to find out the mean and b variance of it. Okay, as we know here that mean is equal to np, where variance is npq. Okay, we don't know the value of p, and that is already given in question 5.13. Let us go to question 5.13 now. So this is question 5.13, and here we can see that what was basically the value of p. Here we can see that a national study that examined attitudes about antidepressants revealed that approximately 70% of respondents believe antidepressants do not really cure anything, they just cover up the real trouble. Okay, so here it can be very clearly see that p is 0.7. okay, so q, which is 1 minus p, that is 0.3. okay, so let us get back to our question. So here, as we have been given that P is 0.7 and Q is 0.3. Okay, so let me put these values here. This N is 5 and P is 0.7. So it would be 3.5. Okay, also here putting the values here, N is 5, P is 0.7. Okay, and Q is 0.3. Okay, so it will be something like 1 point something, or this would be sigma square. Okay, similarly, if you want to find out the standard deviation, which is sigma, so you have to do what? You have to take the square root of this sigma. Okay, so this is what, this is the standard deviation, and we have found out the values by them, and these are basically the answers of our questions. This is 3.5, and this is here, you have to calculate it, and then you will get the answer here. Now let us move towards question 5.18, and in question 5.18, Part A is in exercise 5.9. How many of the 15 trucks would you expect to have blowouts? And B, what is the variance of the number of blowouts experienced by the 15 trucks? Okay, so here it is very clear that in question 5.18, the number of items here are basically how much? These are 15. Okay, so these are 15, and in order to find the mean of it, this is part A, and in order to find the mean of it, we know that mean is what? This is NP, and B is for variance. Okay, this is for variance, and the formula for variance will remain the same, and that is NPQ. Okay, in question 5.9, let us see the value of P, which is here not known. So let us move to question 5.9. So this is question 5.9, and here we can see that in testing a certain kind of truck tire over rushed terrain, it is found that 25%. Okay, so P is here what? This is 0.25, and Q is how much? That would be 1 minus P. So 1 minus P is 0.75. Okay, so these values are known here. So let us move back to our question. So P was 0.25, and let me put these values here. So it would be 15 multiplied by, let me change the color here. So it would be what? NP. So NP is, N is 15 multiplied by 0.25, and here the answer of it will be here. Similarly, for the variance of it, which is sigma square, what I will get here, N is 15, P is 0.25, while Q is how much? We have also found out Q, and that was 0.75, and multiplying with it 0.75 as well. Okay, so this is what, this is basically the solution of question 5.17 and 5.18, which are basically related with the mean and variance of the binomial probability distribution. Okay, so that's it for today, in which we have discussed the meaning and solution of the questions which are related to mean and variance of the binomial distribution. See you soon. Welcome back, guys. I hope all of you will be fine. So this is question 5.19 of chapter 5, and today we have been starting another very important topic that is related to the multinomial probability. Okay, let us first go through the statement of this question. As a student drives to school, he encounters a traffic signal. This traffic signal stays green for 35 seconds, yellow for 5 seconds, and red for 60 seconds. Assume that the student goes to school each weekday between 8 and 8:30 a.m. Let x1 be the number of times he encounters a green light. Okay, x2 be the number of times he encounters a yellow light, and x3 be the number of times he encounters a red light. Okay, find the joint distribution of x1, x2, and x3. Okay, so this is the statement, and in order to solve it, here we can also see that the case here is that we have one light which is green, the other one is yellow, and the third one is red, and each one lights up for a certain amount of time, and let x be the number of times he encounters a green light, x2 be the number of times he encounters a yellow light, and x3 be the number of times he encounters a red light. So we have to find the joint distribution for x1 and x2 and x3. So this would be what? This would be the case of the multinomial probability. Okay, so in order to find the P1, what do we have to do? In order to find P2, in order to find P3, what do we have to do? P1 is the probability of the which light. This will be the first one, which is 35. So 35 is here, P2 is 5, and for P3 I have to write here 60. Okay, but these are the seconds. In order to find the probability out of them, we have to add all the numbers together, which are 35 plus 5 plus 60. Okay, similarly here 35 plus 5 plus 60, and for this 60, 35 plus 5 plus 60 as well. Okay, so from it I will get the probabilities. Let me move down somehow, and here in order to find the P1, what it would be? It would be 35 divided by the number of seconds for the first light plus the number of seconds for the second one and the number of time for the third one, because this is the total time. Okay, this is what? This is for the number of time for the first one, while this one is for the total, which is n1 plus n2 plus n3. Similarly, for P2, I have to write what here? It will be 5 divided by 35 plus 5 plus 60, which would be n2 divided by n1 plus n2 plus n3. Okay, and for P3, I have to write what? 60 seconds divided by 35 plus 5 plus 60. So it would be the n3 divided by n1 plus n2 plus n3. Okay, and finding them out, it will be 0.35, it will be 0.05, and it would be what? It would be 0.6. Okay, adding them all together, we will see that when we will add them together, so P1 plus P2 plus P3, this will be equal to 1. Okay, now taking these values and putting them all in this formula, because this is the multinomial probability and we don't know the number of times that green lights up, the yellow lights up and red lights up. So taking them generally, and for taking them generally, let me take the number of time the green one lights up is equal to x1, and this is the small x1. For x2, this is small x2, and for x of 3, this is small x3. Okay, so putting them up, we have to find the probability of x1, x2, x3. It will be what? It will be the n factorial divided by the x1 factorial, x2 factorial, x3 factorial, and their probabilities, which will be p1 x1, p2 raised to power x2, and p3 raised to power x3. Okay, so let me write their values. Here we have to note down that this is the multiplication all over, and n is equal to x1 plus x2 plus x3. Okay, let me write their values. So n is unknown, x1 factorial, x2 factorial, x3 factorial, and the probabilities are already known. So it would be 0.35 raised to power x1 multiplied by 0.05 raised to power x2, and the last one is 0.6 raised to power x3. So this would be what? This would be probability of x1, x2, x3, and this is what? This is the solution of our question, which is what? Which is related to the multinomial probability. Okay, so that's it for today, in which we have started our problem from a very core concept of the binomial probability law, and we have extended it to the multinomial probability, that how to identify that whether a certain problem is related to the multinomial probability or binomial probability. So if you have any question, you can ask me in the comment box. See you soon. Welcome back, guys. I hope all of you will be fine. So this is question 5.20, and the statement of this question is: according to USA Today, March 18, 1997, of 4 million workers in the general workforce, 5.8% tested positive for drugs. Of these testing positive, 22.5% were cocaine users and 54.4% are marijuana users. Okay, so on the basis of this data, we have to find that what is the probability that of 10 workers testing positive, 2 are cocaine users, 5 are marijuana users, and 3 are users of other drugs. Okay, so here we can see that we have more than 2 categories, which are the categories of the cocaine user. Okay, let me represent it with C. Marijuana users, let me represent it with M, and other with O. Okay, here we will have the total number of persons 10 which are tested positive, and the people we want to see are the cocaine users are 2. For marijuana we have to see 5, while the remaining one are 3 here. Okay, out of these, what are basically the probabilities for them? For it, let me represent it with P of C, and this is what is given here, 22.5%, which is 0.225. Okay, the probability of marijuana users are basically what? The probability for that is 0.544. Okay, and the remaining one is here, which is for O. So for O are basically the other ones. So here it will be 1 minus P of C plus P of M. Okay, what it would be? Let me calculate it. P of O, it would be 1 minus P of C is 0.225 plus 0.544. Okay, so it would be what? It would be 0.231. Okay, so this is here we have. Okay, so now on the basis of it, we want to find out the probability, and here again we have to use the multinomial probability law. So let me calculate it, the probability that we will have 2 cocaine users, 5 marijuana, and 3 other users. So it would be what? It would be the n factorial divided by c factorial, m factorial, o factorial, multiplied by what? Multiplied by p of c raised to the power c, p of m raised to the power m, and p of o raised to the power o. Let me write their values. So here it would be 10 factorial divided by 2 factorial multiplied by 5 factorial multiplied by 3 factorial, and multiplying with them the values it has. So the probability of C is 0.225 and C is 2, so square. Similarly, P of M is 0.544 and it is 5 here, and 0.231, and the power it has is cube. Okay, so now here we have these values. Now calculating it and finding out the answer of it, we found that the answer of it is 0.0749, and that is what? That is basically the solution of part A of our question. Okay, here it is given. Now on the basis of the similar data, let us calculate or find the answer of the part B of this question. What is the probability that of 10 worker testing positive, all are marijuana users? So means we have the marijuana users, total number of positives are 10, and K, which are 10, are basically here, and these are the marijuana users. So marijuana users are here, and the probability of the marijuana users is here. So let me have this one as P. So this is 0.544, and we can see that this is the problem of the binomial probability, because here we have only one category, either a person will be of marijuana user or not. Okay, so this is the binomial probability, only one category has been given, so either a person will be of that category or not. Okay, so let me find it out. So it would be the probability that K is equal to 10. Okay, finding the values here and using the same formulation as we did previously. So it would be 10 factorial divided by this category 10 factorial and other category 0. Okay, the probability of this category is 0.544 and raised power 10, and the other one would be what? It would be q. Okay, so q would be 1 minus 0.544. So the answer of it would be what? 1 minus 0.544 would be 456, 0.456. Okay, so let me write it 0.456 raised to power 0. Okay, so calculating it, these two will cancel out. This would be equal to 1, so it would be 0.544 raised to the power 10. So the answer of it would be 0.0023. Okay, and that is what? That is the solution of part B of my question. Okay, so for solving part C, let me move down somehow. So the statement of part C is, what is the probability that of 10 workers testing positive, none is a cocaine user? Okay, so here if we have the total number tested are 10, so none are basically what? The cocaine users. So others would be 10. Okay, so here the probability of the cocaine users is what? That is here 0.225, and not cocaine users would be q. So it would be 1 minus 0.225, which would be what? Which would be 775. Okay, 0.775. So now in order to find it out, again this is again the binomial probability. So we have to find the probability that k is equal to 0, again using the same formulation, that 10 factorial divided by 0 factorial and other categories are 10 factorial. Okay, which is same as 10 choose 0. Okay, as here we had this one and it was 10 choose 10. Okay, so we have covered all these topics in our binomial probability distributions. So here the probability of it is 0.225 raised to the power 0 because of here, and the other one, which is q, is 0.775 raised to the power 10. Okay, so this is what we have. In order to calculate it, these two will cancel out, it would be 1. So only we have to find this one, which is 0.775 raised to the power 10, and the answer of it would be 0.0782. Okay, so that is what? That is basically the solution of part C of my question. Okay, so that's it for today, in which we have seen 3 parts. The first part was there, this was part B, and this was part C. Okay, in all of these parts we have seen the usability of the multinomial probability distributions and how to use it, how to find different probabilities. So that's it for today. If you have any question, you can ask me in the comment box. See you soon.